Today's lesson is on properties, a few of the properties of equality, including reflexive, symmetric, and transitive properties, and then we're going to name and prove some properties of congruence as well. So, excuse me, we're going to start with this reflexive property business. What does this mean? Okay, so reflexive means you equal yourself. So if we just talk about numbers, A equals A. Segment lengths, AB equals AB, and angle measures, measure of angle A equals measure of angle A. Means that you equal itself. Okay? So, reflexive property, you might sit there and say, well, what's the big deal? Well, that's a good question. It just means that whatever it is, it equals itself. Now, the symmetric property is quite useful, actually. Basically says if A equals B, then B equals A. Or if AB equals CD, then CD equals AB. Or if the measure of angle A equals the measure of angle B, the measure of angle B equals the measure of angle A. That is called symmetry, so therefore we call it the symmetric property. Now, the transitive property is pretty simple too. Think of it this way. If A equals B and B equals C, then A has to equal C. Or if we use segment lengths, AB equals CD and CD equals EF, then AB and EF have to be equal. Makes perfect sense. So if angle A, the measure of, equals the measure of angle B, and the measure of angle B equals the measure of angle C, then these two angles have to be the same. So that's called the transitive property. Okay, so if we look at this here, you reflect the beam of a spotlight off a mirror lying flat on a stage, as shown. Determine whether angle DBA, the measure of angle DBA, that's this one, equals the measure of angle EBC, that's this one. Now you may say, well, definitely, I can tell that. Well, in mathematics, we can never assume, so we have to prove it. I know it kind of stinks, but we do. So I'm going to erase this. Keep the goal in mind. We're trying to prove those big angles are congruent. We know that angle 1 is equal to angle 3 because it's given. So I'm going to say measure of angle 1 equals the measure of angle 3 because it's given. We know that's equal. Okay? Well, what does DBA consist of? 2 and 3, doesn't it? So I'm going to say that the measure of angle DBA is equal to the measure of angle 2 plus the measure of angle 3. And if you remember from a couple days ago, that's the angle addition property. Or postulate, I should say. That was a postulate. All right, so 2 plus 3 equals DBA. Well, how about 1 plus 2? What's it equal to? CBE, isn't it? So measure of angle 1 plus the measure of angle 2, same property, angle addition postulate. Interesting. Let's see. That means then that angle 2 is the same in both, correct? And also we know that 1 is equal to 3. So what if I substitute that in there and rewrite this DBA as the measure of angle 2 plus the measure of angle 1 by substitution? This is kind of your first proof that you've ever seen probably. It's called a proof. We're proving it. Now look at these two things. Now we immediately assume they're equal, they're the same. But this is one of those things where we need to say, okay, we need to say if A equals B and B equals C, then A equals C. This being A, this being B, B, C. That's the transitive property. Okay? It's called the transitive property. So then we know that the measure of angle CBE, we just proved it, is equal to the measure of angle DBA. Pretty cool. Okay? Now, knowing this, let's talk about these properties of equalities and see if we can't figure out how they apply to these situations. If the measure of angle 6 equals the measure of angle 7, then the measure of angle 7 equals the measure of angle 6. So look back in your book at those properties. It's the symmetric property. This can be found on page 468, by the way. How about 34 degrees equals 34 degrees? That is what we call the reflexive property, which means it equals itself. What about 3? If the measure of angle 1 equals the measure of angle 2, and angle 2 equals angle 5, then 1 must equal angle 5. That's the property we just talked about. That's the transitive property. All those properties are right there on page 468. Okay, now I'm going to, this is on 469, example 2, and you can model these things. It's basically a proof just like it was with the angles. I'm not going to go through that. That is on page 469 if you want to follow along with their explanation of this. It makes a lot of sense. I'm going to allow you to do that. We're going to go on to the bottom here of, I think it's 469. We're going to name the properties of equality that the statement illustrates down there below. So if JK equals KL and KL equals 16, then JK equals 16. Right, that's the transitive property. Transitive. If A equals B and B equals C, then A equals C. What about 5? Symmetric? Right. You switch the left and the right. And then the last one is reflexive. It just equals itself. Good job. Now, we're going to skip that example 2 there, hot dog stand. Write a 2-column proof. We just did that. Okay, let's see. This one is on page 470. Okay, we're going to skip that and we're going to get to the using properties of congruence. Now, these are the same properties, but now we're going to apply them to segments and angles. It's the exact same idea, reflexive, symmetric, and transitive. So name the property that the statement illustrates. This can be found on 471. If angle T is congruent to angle V, and angle V is congruent to angle R, then angle T is congruent to angle R. That would be the transitive property. B, if segment JL is congruent to YZ, then YZ is congruent to JL. That is the symmetric. So remember, if you just flip them, if it's symmetric. For transitive, you have to have 3 different things in order to have transitive property. Symmetric, we just flip them. And obviously reflexive is itself. Now it says write a 2-column proof using the symmetric property of segment congruence. And that can be found on page 471. I encourage you to look through that. There's a little button you can listen to the explanation. That's why this book, we need to be a lot more user-friendly. We got the book for that reason. Please use it. It's a very valuable tool. Okay, I'm going to go to this next slide here and talk a little bit about naming the properties again. All right, so what is the property that the statement number 9 illustrates? GH is congruent to GH. Right, that is reflexive. How about if angle K is congruent to angle P, then angle P is congruent to angle K? That is symmetric. And then we're not going to worry about that one there. Okay, now this 2-column proof, we're not going to be doing this yet, but that's coming up very soon. And we will do that with triangles mainly. And it is different. It is basically using deductive reasoning and logic to find the next step. And I look forward to going over that with you very soon. The assignment then is going to be found on page 473, and that's going to be numbers 5 through 18.